Alright YouTube, this is my 6th video in my module on logarithms. In this one we're going to focus on the natural log, okay? What the natural log is, what its graph looks like, and by the time you're done with this you should also be able to use a calculator to evaluate natural logs. So anyways, let's go ahead and start with defining the natural log, and we're going to start by defining this by taking a look at the natural exponential function, okay? So recall that in the past, let me get a color that works here. In the past we've talked about the natural exponential function, which is y equals e to the x, and so this was a graph. I mean, if we were to sketch this graph, we will in a moment, but we say, okay, well, it's an exponential function. E is about 2.718, so we'd say, well, exponential functions, we know that they have an asymptote on the x-axis. They go to the point 0, 1. In this case, if we plugged in 1, we'd get like 2.718-ish, okay? So we'd get this graph looks like this. Fact is it passes the horizontal line test, so its inverse will pass the vertical line test, and so its inverse is a function, and we're gonna talk about this function, but we say since this a one-to-one function exists, we're going to call this the natural logarithmic function, natural log function. And so we use a special symbol to denote this as ln of x, okay, read as the natural log of x. So when you see ln of x, you can think of this as the natural log of x. So I just want to point this out. We say if y equals e to the x is the natural exponential function, then we'd say if we switch the domain arrange, x equals e to the y, switch the x and y around, and now rewrite this in logarithmic notation, we'd say this would be log base, now our base here is e, log base e, and we say e to the y equals x, so e to the what equals x is the y. We say this is our natural log function. So what I want you to know is this is the natural log, natural logarithmic function. We just say natural log. Or you can say ln, because the fact of the matter is this. Previously we said, you know, the common log is log base 10 of x, and we just write it as log of x, and we just understand it as to be a 10 here, even though I didn't write it. What I'm going to tell you is that ln of x that we read up here, we say log base e of x. You can write log base e of x, it's totally fair, but we just tend to write ln of x. And this means the same thing as log base e of x. Don't ask me why we do it, but I like this. I like the abbreviation. It saves me the trouble, okay? So we say, notice here, I say, no, it's okay to write the natural log of x as log base e of x, but people in the math community will look at you a little funny. So we say, we just use ln of x is the accepted way to write it. Okay, so the definition is basically this. We say f of x equals log base e of x is the ln of x, where x is some positive number. E to the what equals this positive number here. We just call it the natural log function. So, you know, I notice, well, I wrote here, I say that its definition implies that the natural log function and the natural log exponential, natural exponential function, they're inverses of one another. And so every natural log expression can therefore be rewritten from this form, y equals log base e of the x, into the exponential form e to the y equals x, which is this form that we've written here. Of course, every log can be rewritten in exponential form, okay? But what this means essentially for us is this: e to the y equals x is the inverse of y equals e to the x, which means their graphs, they get reflected about this line y equals x. So we're going to go ahead and take a look at what this would look like. Starting with this, we're going to graph the function, the natural log, or natural exponential function, e to the x. And we're going to use that table to sketch the graph of its inverse function, okay? Which we know is reflected about this line, this identity function, y equals x. And I'm just going to kind of draw on a solid, and instead of a dotted, we say it's reflected about this. So we say, all right, let's graph y equals e to the x. Well, a few points we know on this. Definitely, if I plug in 0, I get 1, because anything to the 0 power is 1. In this case, if I plug in 1, I get 2.718. How about this? I've got my calculator out here. If we said e, where's my e button? E power of 2. We get 7.389-ish, so we say 7.389. If we say, all right, so e power of 1 negative, we get about 0.368, so 0.368, and e to the power of negative 2, which would be 1 over e to the power of 2, we say e power of 2 negative, and we have this 0.135, 0.135. So graphing this out, this is the exponential function that we're graphing here. We say at negative 2, it's at a height of darn near 0 for our scale at least, and we say negative 1, we're at a height about a third-ish, a little bit above. 0, 1, of course, is on the graph. 0, 1's on the graph, of an exponential function. 1, comma 2.718, as we said, and then 2, comma 7 point, this is like This is like 8 here, and this is 9, so 7.389. It's in here somewhere. So here's our exponential function. We said if we wanted to draw the inverse function now, the domain and range just switch, and so we'd have this asymptote, by the way, here. So the natural log function, y equals ln of x, which is log base e of x. If we wanted to graph this, let me kind of switch it out and say, well, this is our orange one. We could say, well, then our table would essentially look like this. We say x and y. Our domain and range have been switched, so we just take our original table and switch all these values around. So we'd have 0.135 comma -2, 0.36. I'm going to go with that for now for the sake of truncating that. We say 1, 0, 2.72-ish, comma 1, and then 7.39-ish, comma 2. So putting these on the graph, we'd say, well, first of all, the natural log function, just like any parent log function, should have an asymptote at x equals 0, should go through the point 1, 0, which it indeed does go through the point 1, 0. But we say we're flipping all these points over. So 2.718, comma 1, 2.72, comma 1, 7.39, comma 2 is out here. And then we've got a couple other points in here. At 0.36 is our x value, or at -1, and at 0.135 we're about here. So here's our natural log function. It looks like every other logarithmic function. We just have a base of 2.718. This is essentially all you need to know. So again, just like every other log parent function, the natural log function has an intercept at 1, 0. Memorize it, okay? Has an asymptote at x equals 0. Memorize it. All right, and we say log base e of e would be 1, and this is 2.718. So at 2.718, it's a height of 1. Okay. So that being said, I said one more thing I wanted to do is just use a calculator to evaluate this function. So if I said, for example, I want to find ln of 73.25, just wanted to point this out. That's the same thing as log base e of 73.25. It's the same thing as log base. Sorry to do all this writing. I just want it to make sense. We say 2.718. 73.25, and we say if this equals y. Well, we'll do this much writing on the next one, but basically what we're asking is this: e to the power of what? In other words, like a number that is slightly less than 3 to the power of what would be 73.25, and that's what our calculator is going to do for us. So getting this calculator out, we'd say, okay, so we say ln of 73.25, you just get your calculator, 73.25, we'll take the ln of this, the natural log, we say 4.293-ish, so we'd say y is approximately 4.293-ish. And so plugging this back in, this 4.293-ish, I just want to plug it back in here. I mean, you could plug it in up here also, but we'd say 2.718 to the power of 4.293-ish should give us approximately 73.25. So I'm just checking this here. We say, all right, so here's my calculator. We say 2.718 power of 4.293. Hey, we got about 73.25. We round it, so we didn't get it exactly. But we're going to leave the calculator out here because when I'm going to do these last few, we say, all right, so ln of 0.4. What could I take e to the power of to get 0.4? I got smaller, so I'm guessing it's proper fraction is what we took it to. So we'd say 0.4 ln. It's that easy. Oh, a negative number. So we say negative 0.916. So approximately 0.916 negative. Okay, easy to check. We say e to the power of negative 0.916. You should get approximately 0.4. So moving right along, this is kind of an important one. What if I try to take the ln of -2? Remember from a previous video, I'm saying e to the power of what? E to the power of what equals -2. Well, hey, could you take a positive base to any power and get a negative answer? No, it's not going to happen. So again, we say the ln of -2, 2 negative, take the ln of this. It says not a number. Well, the reason why is because it does not exist. Does not exist. There's no answer. So we say undefined would be another proper or appropriate answer here. And we say, okay, so how about this? 2 plus radical 3. What if I had been doing the quadratic formula or something? Let's do that first. So we've got this. I'll bring this up here. We say 2 plus, in parentheses, 3 square root, in parentheses, equals. So 2 plus radical 3 is this. We'll take the ln of that. So, 1.317-ish. So it's approximately 1.317. So not a hard thing to do. Cheers.